So a quick rundown of these sections. We have a location where you can put in the coordinates of your site. So for example, we might say that our site's at 0, 0, unless you've got real world coordinates, and we might have a ground height of 10 meters. Along the side you can see various messages that flag up from the server that talk about validation, and this is because as you type in values it's checking to see what other information you might have in the design that it conflicts with, and this design here probably has pipe levels that were quite different than the new ground level, and so it's picked those up. Let's go and have a look at the pipes in due course, and we'll probably see they're much higher than the ground level, and we'll need to correct them. So project details is the next tab. We go to the project details, we enter a title, reference number, and put our name in here, and you would want to title the job run with something that's meaningful to you, so that you can distinguish it from any of the others that you've done, and so on and so forth. So for the CSO object we have a calculation page here, and if we click that we can produce design calcs for the CSO. That's actually hydraulic calculations. I'm going to rename that to make that more to be more meaningful and tell you that. So you get a little query here, or a little bubble that pops up if you hover over the information sign, and that can give you a clue as a bit more information about what the item is. That one doesn't want to appear very much. I shall make a note of that. There we go. So for this flotation bearing check calcs, when I ticked it, it needs me to give it some information here before it can correctly calculate the bearing capacity and so forth. So that's simple enough. You get some advice here in terms of what you can put in. So if you put in a value that's not permitted in this range, it will probably tell you that. Yep. So it says it's failed to validate against the requirements between 20 and 40. So let's put that back to 30 or 28, I think it was. And so on and so forth. Model data, we've got some validation flags here. This is because when we changed our ground level to 10 meters, the rest of our levels in our design need to be updated as well. So having a weir level that's 283 meters high, or 283 meters above sea level, is clearly out of step with the new ground level we put in at 10 meters. So we could change that weir level. We could say that it's maybe a couple of meters under the ground. Let's say 8 meters. Let's keep our hydraulic information the same for simplicity. We get now warning validation messages because there's still other items here that are not valid yet. So we'll keep getting those until we've ironed them all out. This is spill data that comes from the model that your team has probably done on a piece of software like InfoWorks or micro drainage or so on. 10 years peak spills, let's leave these the same. Spill frequency, depending on the spill values you put in, you get some feedback saying whether the type of, telling what type of screen you need. So in this case it's saying an unpowered screen is suitable for this flow rate. Okay, let's try putting in 150 and see what happens. Does it still say that? So getting some more data here. When it's finished echoing those changes, it's saying an unpowered screen is suitable. Let's try adding another naught. Now it's telling us it's too large for that screen. Another thing that might be, let's pop it back to what it was. Another thing that might be that would affect the type of screen would be the spill frequency. So typically 2 spills a month, or more than 2 spills a month, which is 24 a year. More than that will require a powered screen. So let's see if that message updates as we change our data in there, and it should, spills too frequently for an unpowered screen. So whilst it lets you put those data, that information in, it's giving us feedback there. Let's put that back. I don't know, 10 spills. We've got a top water level here, which is clearly not going to work with our new ground level. So you would go back to your model, your hydraulic model, and you'd find out what the 5-year top water level is. Let's pretend that it comes up a little higher than the weir by a quarter of a metre, and again the 30 year. 30 year might be a little bit higher again, and that's us. So that this model data will come from your hydraulic model, and you'll need that to produce a meaningful design. So moving on to the pipes, this is where we get into stuff that's more familiar to all civil engineers. So we might have a concrete pipe, or a plastic pipe. Let's go with concrete. Let's say we want a 450 as an incoming. Now the incoming levels, again, you can see these have got their issues, because it's expecting something that's no higher than 8 meters, our ground level. So let's put in, if we had a weir level of 8, so let's put in a metre and a half below that, or 2 metres below. Easy numbers, 6 incoming pipe level of 6, and let's make our outgoing pipe level 5.8 or something, to avoid the water trying to flow uphill, which is what it's currently found. And let's make the outgoing pipe slightly smaller, so let's make it a 375. It's telling us that our current setup gives us a velocity in the channel of 1.35 and a 2 times dry weather flow depth of 15, which looks reasonable. And we can set some of these other options. It's the overflow pipe, we've got a 300, and let's make the invert level, if we've got a weir at 8, say 7.5 metres, and let's leave it at that. We can choose a screen. So here's a hydraulic peak screen, the peak screen selected. We could tell it to auto select for us. If we're not sure whether a powered or an unpowered is the best, and it's going with our previous choice of an unpowered one. If we decide that we actually want to have a powered screen here for some reason, even though it wouldn't be the usual, then we can then select from 2 manufacturers there. Under Hydro-Rock we've got 2 types, a Max 90 or 180 model. The 90 is a bit shallower, but can't pass as much flow. So if we've got space for a 180, you can normally have a smaller, shorter chamber. And it's selected one of those products, which is fine. Or we could have chosen a Longwood if we went for a Longwood manufacturer. It's offering us a storm guard, and I'll wait for the server to catch up on the right hand side, and it's giving us one storm guard 200, which is what it's requiring. We can allow space for a launder channel. At the moment, the program just allows space for it rather than designing it, because it's a bit of a specialist piece of kit, and it will just give you the spatial set out the space in the chamber so that you can add that into your CAD model. But it's not always required. It's not usually required, but you can add it in if you wish. That's added in. So then on our chamber, so this is where you'd set in the width and spacing upstream and so on for your launder channel, if you wish to have one. So let's turn that off for now. Moving on to the chamber, there's some rules in here which are bespoke to Scottish Water that we were designing to, which we can switch on or off. Then we can decide to use precast units, which means the chamber length and width will be based on fabricated off-the-shelf products. So at the minute that's unticked, which gives us our minimum length and width. If we check that, it will make it use off-the-shelf products, and it will round up the chamber size to the nearest off-the-shelf product that's bigger than what is required, or shall we say no smaller than what is required. You can force a 1 in 30 slope in the dry side chamber. It's currently calculated theoretical value of 1 to 24.2 for self-cleansing, but 1 in 30 was a typical Scottish Water standard. Weir construction, you can go for steel if you want it to be smaller, but support brackets can often cause ragging with steel, so let's keep with concrete for the time being. Chamber spill direction just simply is your chamber going to spill across the weir to the left hand side or to the right hand side when you're looking in the line of flow. Overflow orientation, this is the overflow pipe can either be coming out parallel to the incoming and outgoing pipes, or it can be coming out at 90 degrees or perpendicular to that. Set that as you wish. And cover slab thickness. This is for you to put in your own value. It's defaulted to 300 here. It's using a sort of a span over 20 rule of thumb, but the DynamicObjects does not give you structural calculations, so it's a GA, so it will give you whatever you put in there, but it's giving you a starting suggestion, and it's offering you a range between 116 and 500 as sort of minimum and maximum criteria. You can override the slab level, for example if you want it to protrude above the ground or below the ground, but normally you wouldn't wish to do that. It's calculated a slab level of 9.8, which is below ground level by 200. You might want to say, well, look, for the sake of 200 millimetres, we'll make it 9.5, or we'll make it, stick out of the ground, or make it flush. Another way of making it flush is on the lids chamber, which will give us an option to make it flush there, so we'll take that one. Wall thicknesses and so on, you can change as you wish. The base slab depth, the bigger it is, the heavier the chamber will be, and it will help with buoyancy or anti-flotation. You've got some data fed back to you here. Concrete weight alone prevents flotation. CSO is very heavy. Bearing capacity, factor of safety 0.9. Factor of safety against flotation 3.6. So that's actually not given us a factor of safety of 1. So it's very heavy for whatever bearing strength we've got in the data. When we went to our calculations page, we put in a bearing capacity of 145. So that's interesting to see that, because it's saying that the chamber is very heavy and could actually be crushing the ground beneath it ever so slightly. So that might be one to look at, a detailed design. so you get that information to hand. You could, if you wish, reduce that slab depth and see if that helps. If you've got a problem with flotation, which we don't, you can always increase the toe length at the bottom of the chamber. And we've got a mechanical electrical page, which at the minute is very simple and probably get more sophisticated in due course, but it's offering us different ultrasonic types of probes and ultrasonic level sensor types, both or none. Ultrasonic's pretty normal. You can have a kiosk included in the model, and you can have a workman included just for a sense of scale. And then moving on to the lids page, we can set the lids to be flush with the cover slab, and that will bring the normally speaking, that will bring the cover slab flush with the ground, because that's where the lids are usually, unless you make it protrude out above the ground. The alternative is if it's not flush with the slab, then the CSO will end up with sort of chimney risers above for each of the shafts where access is required, and it will build that for you. So we'll leave that for now. Man access lids, you can select whatever rating you require and the different types of manhole cover within that rating. So we'll stick with the defaults. We've got very small covers here, 675 by 675. 450 by 450, you could make it that, but probably be in breach of your water company requirements. Some require 900, so let's choose 900. It'd probably make the chamber quite a bit bigger, but access will be that much easier. Now, man access can be via ladder, step irons, or none. Good hoist only. So we'll keep with the ladder for now. And the level sensor has its own access lid normally, and again you can choose the nature of it, and it's choosing the smallest one available for that level sensor type. Now this option allows you to have one access hole above the screens, and if you've got more than one screen, you can tick this and it will create a single clear access across all of the screens. So if you had 3 screens on the weir, you'd have a single clear access across all 3. Now the alternative is that you have a access that's just above each screen, and the program will try and minimise the size of that access if you wish, which will give you the smallest access size that you can theoretically take that screen out from. So it's sort of actually explained better there than the way I've just explained it. But you've got a choice there. I'm going to opt to have the full length of the screen so that the screen can be lifted out directly without having to rotate it round or upend it first. The screen access lid can again have a number of different types. You could go for ductile iron, split triangle, if there's a lid available, but you can see in this case there isn't. So we'll go with solid top trench covers and see if there's a product available. And there's a 3-leaf 600 by 600 that fits. Although it's recommending a solid top trench 165 3-leaf. Yes, that is the one it's recommending. So that's fine. We'll leave that the way it is. Override. We can override the inlet lengths and the outlet lengths, which are normally calculated if we have a reason to. So if you tick the override button, it will offer you the choice to to put in an override, but we're going to leave that. And then we have a design review tab at the end, which is just giving us some information about our design. So this first one here, hydraulic jump is likelihood. A hydraulic jump cannot form if the flow entering the chamber is subcritical. If the flow entering is supercritical, a hydraulic jump will only form if the flow exits subcritically. And it's telling us that flow is supercritical in the chamber and a hydraulic jump can form. So we might have to go and look again at our gradients. The tick box is really just to say that you've read it, you've acknowledged what you've acknowledged the comment. And it doesn't let you uncheck it when you've checked it. It's keeping track of that. Inlet pipe length. The document FR0488 recommends that the inlet pipe should be a constant diameter for a length of 25D upstream of CSO. This is really just advice for you. Then we've got inlet pipe diameter, and some, again, you can read through all of those in your own time, and they're generally self-explanatory. Most of them are okay. Then we've got the design overflow pipe for hydraulically short conditions. And this is saying that the design is suitable for an overflow pipe that discharges above the receiving water level. So if your overflow pipe discharged underneath the receiving water level, for example, if it was a tidal area where the outfall was sometimes submerged, you might have to review your design. But if your overflow is discharging above the receiving water, then you're okay. And then we've got some head losses and other calculations and everything else, self-cleansing, so on, headroom. So it all looks okay. So if we're happy that there's no validation errors along the side, and that we've got rid of them all, we've finished our design, taken a bit of time, but we can now come back in the future and make variations on this if we want for optioneering, and we don't have to enter it all in again. So if you hit build, you get a disclaimer telling you that DynamicObjects is not a structural design or a construction ready design. You can't just hand out the design now to a contractor and say build it. And it's not a detailed M&E design either. You can read the full terms to conditions in a normal way on the website. It's filled in a design name based on the project details over here that you put in, and it's got your email address from before. So if you accept the conditions and hit build, that's it, sent to the server, and the server is now building your design. And when the server has finished building your design, it will ping you an email saying it's ready to download. And here it is here, my project demo, August 15, and the design build time and the time taken. So on this option, I can either create new, or once it's been sent to me, for example, this one here, you can order it again. And the difference between those two options is that one will just repeat the exact same design, and the other one will take you back to the design form with all the design data that you had put in, to allow you to make a few tweaks and adjustments before you resubmit it in order to make a variation of it. And that's it. So that's and then we can go back to the catalogue or the home page. So that's the CSO object, and in another video we'll do the pumping station object. So I hope that little demo was helpful to you, and thanks for listening.